The Motor Insurance Repair Research Centre was established in 1970 by the British motor insurance industry to research into every aspect of vehicle body repair. In the course of this research, Thatcham has produced a report on motor vehicle glazing, which contains information on the most commonly used systems. There are two methods of fixing used by vehicle manufacturers: direct glazing and indirect glazing. The direct system involves the use of a bonding agent between the glass and the car body, while the indirect system makes use of a rubber surround to hold the glass in position. This program will demonstrate the replacement methods used at Thatcham, concentrating on the techniques required for screens bonded with polyurethane, which are increasingly being favoured by vehicle manufacturers. It will also show the skills and equipment needed to deal with other adhesive materials and with indirectly glazed screens. There are three basic methods of removing directly glazed or bonded screens: the hot knife, the oscillating knife, and the piano wire. Whenever removing screens, the operator should always be guided by the method outlined in the manufacturer's literature. Similar information is given in the Thatcham methods manuals. The operator starts to remove the mouldings. Slight heat applied with a hot air gun can often make the removal much easier, and it reduces the risk of causing damage to the moulding. The hot knife is provided with a range of blades to suit screens on different models. A compressed air supply is required, which will feed through the holes at the base of the blade. This both cools the base of the blade and helps to keep the cutting edge at a constant temperature. The variable control on the base unit allows the temperature to be raised when cutting through older and consequently harder bonding material. Setting number 8 is required on the majority of screens. The blade is inserted at the bottom corner and pushed up and round to the center of the top of the screen. For protection, the operator is wearing gloves, goggles, and a charcoal filter mask. Care should be taken not to allow the blade to overheat, as this will cause excessive fumes. Throughout the cutting operation, the blade should be kept immersed in the bonding material and parallel to the windscreen frame. Using intermittent pressure on the trigger switch, the blade is brought back to its starting point. A cut should then be made along the bottom of the screen to the center. The same procedure is followed for the other half of the screen. Here, the operator removes the outer moulding by cutting it away with a sharp knife. He has to destroy the moulding in this way because during original fitting the screen dropped down and trapped the rubber between the glass and the car body. Any attempt to remove the moulding intact could damage the screen. Having cut all round the screen by the side of the glass, he is now able to prise out the remaining section of the moulding, which then pulls away easily. The oscillating knife, like the hot knife, is able to take a range of blades to suit screens on different models. The blades have ground cutting edges and can be sharpened on a carborundum stone. Whichever of the two knives is being used, information on choosing the correct blade can be found in the tool manufacturer's literature. The rate of oscillation can be adjusted as required, depending on the age of the adhesive. However, the operator has found from experience that setting number 6 usually gives the best results. The oscillating knife is very quick to use, but it's important to keep the blade parallel to the screen frame in order to avoid damaging the glass, the car body, or the interior trim. Protective goggles, ear protectors, and gloves should be worn. However, despite the very high rate of oscillation which is required to cut through the bonding material, there is very little risk of injury occurring to the operator. Additional preparation is required before using the piano wire to remove a screen. The A-post trim must be removed to give access to the aperture from inside the vehicle. The molding is easy to remove in this case. Since it does not run along the base of the screen, it can be prized up at one end and pulled out. The hot knife and the oscillating knife will both cut straight through spacer blocks, but when using the piano wire, they must be removed in advance. About half a meter of cutting wire has been attached to the anchoring handle. Using a pair of pliers, the wire is pushed through the bonding material and the pulling handle is attached on the outside. The piano wire is obviously the cheapest of the three tools, but it does require two operators. The operator on the inside anchors the wire, which is then pulled from the outside, cutting through the bonding material as it goes. Both operators are wearing protective goggles and gloves. Goggles are especially important when using piano wire, since serious eye damage could result if the wire snaps. Using the cheese cutting action, the wire goes round this corner without difficulty. However, it may sometimes be necessary to use a sawing action. This should be avoided if at all possible, since it can cause damage both to the vehicle and to the glass. In addition, the wire could overheat, causing it to snap. On some cars, such as this Montego, it will be found that it's difficult to gain access to the adhesive bead on the base of the screen, since it's below the level of the dash. When using the piano wire in these circumstances, a different cutting method is required. Since the operator is not able to anchor the probe on the inside, he holds it tightly while the operator on the outside pulls as usual. For the oscillating knife, there's a special long blade available which enables a cut to be made on an adhesive bead where access is difficult. Likewise, there's a special blade for the hot knife for use in this situation. Whichever equipment is used, once the adhesive has been cut through all the way round, the screen can be removed. A large screen like this should always be handled by two people, and it's advisable to store it in a proper rack. In general, the removal of all front, rear, and side screens can be achieved using the three basic methods already shown. However, quarter lights can sometimes be a problem when the surrounding trim is held in place with clips attached to the glass. When using the piano wire method to cut out the screen, these clips need not be removed, since it's possible to cut round them. It's often advisable to use masking tape round the edge of an aperture to protect the paintwork. The rear screen and quarter lights on the Montego have similar clips. VAG have developed a variation on the piano wire method for use on the Audi 100. The kit includes 2 relay rollers, a center reel, and 7.5 meters of cutting wire. The wire is positioned all round the screen under the trim molding and affixed to the reel via the relay rollers. One operator is then able to cut through the bonding material just by turning the ratchet on the center reel. Before refitting a screen, any adhesive remaining on either the frame or on the screen should be cut back, leaving only a thin layer. If using a different bonding material to the original, it should be removed altogether. The oscillating knife can be used for this purpose, but it should not be used on the screen since it may cause damage. The hot knife can be used on both the screen and the frame. Special blades are required for both knives. It's important to replace the screen with the same adhesive as was used during manufacture. The necessary information can be found either in the Thatcham methods manuals or in the manufacturer's own literature. In this case, a polyurethane is required. The screen is cleaned all round the edge with a spirit base wipe. The screen frame is similarly treated. Primer is now applied all round the edge of the glass and round the screen aperture. There are two types of primer to be used. The screen requires a special glass primer. For the screen aperture, there is a separate body primer. Priming will help to ensure good adhesion. Polyurethane is a highly viscous material which allows considerable screen movement during alignment. To prevent the screen from dropping after it's been positioned, spacer blocks are placed round the edge of the aperture. At this point in the replacement process, some vehicles, such as this Nissan, require a dam to be fixed round the screen. Double-sided tape is placed all round near to the edges of the screen. The rubber dam is then fixed to the tape. The exact position of the dam is specified in the manufacturer's repair manual. When the adhesive is applied, the dam prevents it from spreading. On the Montego screen, the mouldings are now being replaced. Different manufacturers recommend that mouldings should be refitted at different times during the screen replacement process, so the manufacturer's own literature should always be consulted. Here at Thatcham, experience has shown that it's easier to fit the moulding before positioning the screen in the aperture. The moulding is held in position with masking tape. The polyurethane should be heated gently before use. A small oven such as this is ideal for the purpose, but a bucket of hot water is equally effective. The temperature is set at about 60 degrees centigrade, and the adhesive left in the oven for about 15 minutes. Some containers are supplied with a pre-cut nozzle, otherwise the nozzle must be cut to shape. A compressed air gun is to be used here. Having pierced the seal and attached the container to the gun, a test bead is laid down. Depending on the consistency of the adhesive, it may then be necessary to adjust the air pressure. The adhesive can now be applied all round the edge of the screen. The gun should be kept as vertical as possible to ensure an even flow. In general, the bead should be triangular in shape, about 7 mm wide at the base and 12 mm high. When the screen is offered up, only light pressure should be required to fix it permanently in position. This job requires extreme care, and it should never be attempted by just one operator. The vehicle should be left for a minimum of 2 hours, but preferably overnight to allow the adhesive to cure. There is always the risk of one of the car doors being slammed shut. The door windows are therefore left open to prevent any such increase in air pressure, which might disturb the newly fitted screen. Next day, the screen is tested to ensure that it's watertight. A more efficient test can be carried out using ultrasonic equipment. The transmitter is placed inside the car and the receiver is run around the edge of the screen. If any leaks are present, the red light is activated. The leak should be sealed by pumping in a small quantity of polyurethane. This can be pushed under the screen with a knife, and the area should be retested. The screen should be cleaned before the car is returned to the customer. There are other bonding agents which are sometimes specified for directly glazed screens. The rear screen on this Nissan Stanza is bonded with both butyl and silicon. When removing the screen, it's necessary to insert wedges at regular intervals during the cutting operation to prevent re-adhesion of the butyl. The usual preparation procedures of removing the old bonding material, cleaning with solvent and priming have now been carried out. The butyl tape is placed all round the edge of the screen. Care should be taken to avoid touching the contact faces of the butyl, since this will reduce the strength of the bond. The silicon is applied to the top and bottom edges only. A vehicle requiring nothing but silicon should be treated throughout with the same method as was described earlier for polyurethane. Butyl is a low viscosity material. Great care is required when offering up the screen, since a secure bond is formed on contact, allowing no further movement. Some manufacturers, such as Volvo, recommend the use of a special fitting jig to ensure correct positioning during replacement. Here, tapes have been used to align the screen accurately. When bedding in a screen bonded with butyl, it will be found that more pressure is required than needs to be applied to a screen bonded with polyurethane. Vehicles requiring Solbit are seldom found nowadays. Solbit contains a resistance wire which, when attached to a transformer, heats up and softens the adhesive, allowing the screen to be removed. Similarly, during screen replacement, the Solbit is heated both before placing it round the aperture to make it viscous, and after inserting the screen, it's heated to cure it. There are two basic types of indirect glazing, the grommet type weather seal on the left and the Clayton-Wright weather seal on the right. The grommet type is much more common and is the one used here. Replacing indirectly glazed screens is much easier and quicker than replacing directly glazed screens. If there is a plastic insert, then this is removed. A metal finisher does not require removal. Using a broad-bladed tool, the rubber is prized over the flange all the way round the screen, taking care not to damage the rubber. The screen is now free of the car body and can be lifted out. Little preparation is required to refit the screen, but the rubber should be examined for any damage and replaced or cleaned if necessary. A draw cord is fitted into the rubber around the flange groove. Soft soap is added to assist in easing the screen into position. If a sealer is specified by the manufacturer, this should be applied now. The screen is offered up, taking care to ensure that it's correctly aligned in the aperture. While applying pressure from the outside, the draw cord is pulled. This raises the rubber over the edge of the pinch weld and secures the screen in position. A second operator would be required on a front screen to apply pressure from outside. The screen should be tamped down to make certain that it's properly settled in. Soft soap has been applied all round the insert channel. There are special tools available for fitting the various types of insert. In this case, a blunt screwdriver proves to be just as effective when used with care. The screen should be tested to see that it is watertight and then cleaned. The Clayton Wright weather seal is not often found, except on BMWs, early Austins and Minis. Having pulled out the insert as before, it was found that the screen had been sealed at some stage, so it was necessary to run a screwdriver all round underneath the rubber to break the seal. By applying a constant steady pressure, it is now possible to push out the screen at the top corners. The bottom of the screen can then be lifted out of the rubber. The rubber is peeled away, revealing the sealant, which should all be cleaned off as far as possible. Replacement is equally simple. After cleaning and checking, the rubber is fitted back onto the aperture pinch weld. With the Clayton Wright system, the rubber is attached to the screen frame, not to the glass, as was the case with the grommet-type weather seal. Having applied soft soap all round the glass channel, the bottom of the screen is placed in position. The operator then prizes the rubber over the edge of the screen, starting at the bottom corners, working up the sides and round to the center at the top of the screen.